Just make sure you draw it big enough and label it with everything that I want done. Leave spaces between problems. Keep answers beside the work. Okay? Now, let's talk about number 15. Okay? Because I want to make sure everybody's cool on number 15. So if you read 15, driving 20 kilometers per hour stops the car in 3 meters. Traveling 40 kilometers per hour stops the car at the same acceleration. Draw motion diagrams, how far, da 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 da. So here's the story. What are you missing on problem number 15? What variable do you not have? Time. On 15, you do not have time. So what are you going to use? So right away, I know I'm going to use that equation on number 15. Okay? Boom. Home run. I know I'm going to use that equation because it doesn't have time. You have 20.0 kilometers per hour. Now, on the front of this assignment, I tell you, all calculations must be done in the MKS system of units. Is 20 kilometers per hour in the MKS system? No, it's not. So quick refresher. You have 20 kilometers per 1 hour. 1 kilometer is how many meters?
1,000.
1 hour, 3,600. Kilometers cancel out, hours cancel out. The shortcut version is that you multiply by 10 and you divide by 36. When you have the 20.0, how many significant digits are there in 20.0? 3, because you count at the 2 and you count over to the right. This has 3. So when you do this conversion, you have to keep at least 3 digits when you convert that into meters per second. So somebody take 20 times 10, otherwise known as 200, and divide it by 36. What do you get?
5.5 repeating.
5.5 repeating, right? So at a minimum, write that as 5.6 meters per second. Don't round it to 6. Don't call it 5.5. You need to keep at least 3 digits when you do that conversion, okay? At least 3. You can do 4, but keep at least 3. When you get down, you're going to have problems from your textbook, okay? So now we're going to start to use problems from the textbook. So let me explain what I mean by the questions and problems. So when you go to the end of any chapter, okay, like when you go to page 56, at the end of every unit, there's a set of assessments that literally called questions, and then you have another set that says problems. Typically, the questions are multiple choice, okay? Not always, but typically that's where you see that's the more conceptual part. Sometimes you'll see numeric values in it. And then you have the problems. You're going to follow the same format. Answers on the left, work on the right, okay? So if you want to make a nice note that says, oh, Mr. Burkamp, here are the textbook problems, so I know that you're transitioning from one to the other, that would be cool. So, and yes, I know the odd answers on some of these are in the back of the book, okay? I love it when students act like teachers don't know that. It's like, I can't know the odd answers. I picked the book, okay? I know the odd answers are in the back of the book. Now, let me explain the dumbest thing you could possibly do. Let's say you work a problem and you have the wrong answer. And I've seen kids do this. And they go, man, the answer should be 14 and I got 4. And I've seen kids do this. They don't change the work. They just take their pencil and erase the wrong answer that they had and write in the correct answer, okay? Without changing the work. Let me give you all a hint when you take the test on Friday. If you flip the test over and look at the back, what are the odds that the odd answers are going to be on the back of the test? 0, okay? So you can use it as a guide, but if your answer is wrong, just, change the answer. answer. No, you did something wrong. Okay? All right. This is gonna take you a while. I'm telling you, do not think, oh, I can get this done in 10 minutes. This assignment's gonna take a while. The one tomorrow night's gonna take a while. Okay? So just be aware. You had a 3-day weekend with no homework, so now it's time to pay the fiddler. So don't forget, test on Friday. Okay? All right.